Geometry 6-3 tests for parallelograms. So we're going to do about half of this page as you just copy down what I've written, and then we'll do some examples together. Conditions for parallelograms. So you remember on 6-2 we talked about attributes of parallelograms, how the consecutive angles are supplementary. We talked about the opposite sides are congruent, opposite sides are parallel, opposite angles are congruent. We talked about the diagonals as well. And so here are our conditions for parallelograms. So this is like we're testing to see if a certain polygon is a parallelogram. If both pairs of opposite sides are congruent, then your quadrilateral is a parallelogram. If both pairs of opposite angles are congruent, then the quadrilateral is a parallelogram. If the diagonals bisect each other, then the quadrilateral is a parallelogram. So remember, bisect each other means that the two diagonals cross each other right in the middle of both of those. If one pair of opposite sides is both congruent and parallel, then the quadrilateral is a parallelogram. So this one is a little bit interesting here. If the opposite sides, just one pair, is congruent and parallel, then you know it's a parallelogram, because if you know this information, you know these sides also have to be parallel and congruent. Okay. Now let's do some examples. Number one. Okay, so we're just checking to see, are these parallelograms? Here is something that looks like a parallelogram, but I don't know if it is yet. So this is F, G, H, J. JH is 14 inches. H is 80 degrees. G is 100 degrees. And FG is 14 inches. Okay, so now let's find out whether this quadrilateral is a parallelogram. We can see right off the bat that these two opposite sides are congruent, but that's not enough to say this is a parallelogram. If these two sides are congruent, then we need to somehow prove that they're parallel as well, and then we can say this is a parallelogram. If these two interior angles, consecutive interior angles, are supplementary, then we know that these two lines are parallel. So remember, if these two lines are parallel, and here's our transversal, if these two interior consecutive interior angles, if they are supplementary, then we know that these two lines are parallel. Therefore, this line segment and this line segment are both parallel and congruent. Yes, this is a parallelogram. Let's look at another one. If I have a parallelogram, or possible parallelogram, I don't know if it's a parallelogram yet, 12 centimeters, 12 centimeters, 5 centimeters, 5 centimeters. Look, opposite sides are congruent. So yes, I have a parallelogram. Let's do number 3. Oh, let me draw it so it looks a little bit more like a parallelogram. Okay, these sides are congruent. This angle here is 85 degrees, and this angle here is 85 degrees. Is this a parallelogram? Now, in the book, this says no. No, it's not a parallelogram. And I think the reason is because we're not totally sure whether these two sides are congruent. I mean, they are congruent, but we don't know if these are parallel. If I had this angle and these were supplementary, then I know that we'd be good. If I had these two angles and they were congruent, then I know that we would have a parallelogram. But we don't have that information. I think we could work through this logically and say this is a parallelogram, but at this time we don't have enough information to do that. So no is the answer. Okay, let's keep going. We've got one more example, and this is a coordinate plane So here's another example, and this is coordinate plane geometry. Okay, so I've got, we're doing the same thing here. We're trying to figure out whether or not this shape that we're going to have here is a quadrilateral. So I'm going to have fairly large delineations here, so I can be as accurate as possible with this quadrilateral. Well, we'll see if it's a quadrilateral or not. So I've got K, L, M, N. K is 2, 3. L is 8, 4. M is 7, 2, oh, negative 2, 7, negative 2, and N is 1, negative 3. All right, notice I left a little space between here. You'll see why in a minute. 2, 3 is K. 2, 3. There's K. And then L is 8, 4. Well, 1, 2, 3, 4, 5, 6, 7, 8. And then up, there's 3, and there's 4. And that's L. M is 7, negative 2. So that was 8, 7, negative 2. N is 1, negative 3. All right, there is my four-sided shape. It looks like a quadrilateral, but I don't really know for sure. So there are a couple ways you could figure this out. You could count 1, 2, 3, 4, 5, 6. We go up 6 and to the right 1 for Kn. So let's go up 1, 2, 3, 4, 5, 6. Oh, I think I might have miscounted that. And to the right 1. If the slope is the same between these two, but not just the slope, but well, if the slope is the same, then these are parallel. And so I could check to see if these slopes are the same and these slopes, and then I know these are parallel and these are parallel. So, and I can do that by counting like that, but I'm not totally clear. If I would have done this on a really nice grid, then I could be sure. But I'm not totally sure. And so what I'm going to do is I'm just going to find the slope between a bunch of these points and see what I got. So I'm going to do x1, y1, x2, y2, and I'm going to find the slope of KL. And so 4 minus 3 over 8 minus 2. That's going to get me 1 over 6. 1 6. So the slope of KL is 1/6. KL 1/6. Up 1 to the right 6. So let's check NM. NM, x1, y1, x2, y2. So let's see, I'm doing the slope of MN. So negative 3 minus a negative 2. Negative 3 minus negative 2. over 1 minus 7. So negative 3 plus 2 is going to get me negative 1 over 1 minus 7, which is negative 6. Negative 1 over negative 6 is positive 1 over positive 6. So 1/6. Okay, now you try find the slope between these two guys, LM and KN. So do that, and then we'll check to see if this thing is a parallelogram. Go. All right, let's see how you did here. So I'm going to check the slope for LM. That one right there. Okay. So I've already got it labeled just fine. I've got 2's and I've got 1's. So 4 minus negative 2 over 8 minus 7. 4 plus 2 is 6 over 1 is just going to get me 6. So this is 6. And then let's look at Kn. Let's do it over here. Slope of Kn equals y2, which is negative 3, minus y1, which is 3. Wait a second. Yep, okay, minus 3, yep, over 1 minus 2. All right, so negative 3 minus 3 is negative 6. 1 minus 2 is negative 1. So that gives me positive 6. There we go. So these two sides are parallel. These two sides are parallel. I have a parallelogram. Yes, I have a parallelogram. And that is 6-3. Good luck on the homework.